Can you follow? Right. So here we have workings. Yeah. Right. Now the first one, break-even point and margin of safety. Part 1. We have break-even point in revenue, now the revenue measurement here is in euro. So we take our fixed costs of 120,000 divided by 50% should give us 240,000. Okay. Then we have our margin of safety, which is expected sales 300,000 minus break-even sales is 240,000. That gives me 60,000. All right. So I don't think part 1 is all that complicated, right? Part 2. Part 2A says discuss the effects of foreign exchange and treated as separate change the basic data. What happens if your fixed cost increases by 20,000, right? Yeah, so the first one, fixed cost increases by 20,000. So you have revised fixed cost will be 120,000 plus 20,000 equal to 140,000. All right. So your break-even point becomes 140,000 divided by the contribution to sales ratio. That is 280,000, right? And your margin of safety now becomes 300,000 minus 280,000. The margin of safety is only 20,000. And now, number 2, that's A actually, sorry. Next is B. Right, now part B, it says a decrease in variable costs of 10%. Decrease in variable cost of 10%. Now, so variable cost is now 10%, reduced by 10%, revised variable costs will be 150,000 reduced by 10% times 90% gives me 135,000. Right, and revised CS ratio, revised contribution, sorry. Let's do a contribution first. Sales is 300,000 minus 135,000. That is 165,000. Revised contributions. So revised CS ratio is now 165,000 divided by 300,000. So that must be 165 over 300, 55%. Okay, so break even point is now fixed cost will be the original figure 120,000 divided by 55%. Right, so not figure. So your margin of safety increases 300,000 minus 182. So 300,000 18182. That's B. Next is C. Now, part C is increase the selling price in 10%. Increase in selling price of 10%. All right. So I'm going to assume no volume change. Only price increase by 10%. Yeah. So that means revised sales 300,000 up by 10%. So now the revised sales will be 110%, 330,000. Revised contribution will be 330,000 minus original 150,000 will be 180,000. Correct. So revised CS ratio is now 180 over 300, must be 60%. Right. So now your break-even point becomes fixed cost 120,000 divided by 60%. So 120 over 0.6 is 200,000. Margin of safety. Budgeted sales was 300,000 minus 2. Right, yeah. Minus 200,000. That is 100,000. Can you follow? All right. And the last one, increase in sales volume of 10%. Increase in sales volume by 10%. Now listen, if your actual sales volume increases by 10%, that means no change in CS ratio and fixed cost. Remember, we are talking about volume change, number of units increasing, not necessarily what do you call it? Not necessarily the change in CS ratio. Let me explain this. Sorry.
For the C revised CS ratio, it should divide by 330, isn't it?
No.
Oh no.
100 revised CS ratio selling price. Oh yeah, you're right. This is 330,000. So that must be 180 to 330, 55%. 55%. Right? And margin of safety is 218182. All right. That is 218182. Yes, you're right. Okay. Now next, no change in CS ratio and fixed cost. Let me explain why. Yeah. You see, you have sales revenue 300,000, variable cost 150,000. Now you have volume up by 10%, correct? So if your volume goes up by 10%, it means this becomes 330,000. This becomes 165,000, correct? Now, so contribution to sales, contribution is 150,000, and that becomes 165,000 or so. So if you calculate your CS ratio, this is 150 over 300, 50%, also 50%. In other words, no change. Can you follow? Now, if there's no change in CS ratio, that means the break-even point and the margin of safety will remain unchanged. Can you follow? It will remain unchanged. There shouldn't be any change in the break-even point or in the margin of safety. All right. Okay. Now, the break-even point doesn't change. Margin of safety won't change either. All right. Now let's look at the next question. Here, question number 3. Company has the following revenue and cost for a single product that it manufactures. Company has selling price per unit of 12 and variable cost per unit of 840, annual fixed cost 720,000, normal annual volume of 540,000. So this will work out the contribution per unit, profit volume ratio, which is the contribution to sales ratio, break-even point units and value, margin of safety units and value. Right. So on another sheet. First of all, I want to find the contribution per unit, which is 12 minus variable cost is 840. It'll be 360, right? 360. So we're supposed to work out, yes, contribution per unit. Number 2, profit volume ratio, PV ratio will be 360 divided by 12. So 2436, so 30%. And then we have break-even point in units and value. So first we're going to find the break-even point. Now, in units will be fixed cost divided by contribution per unit. Now, your fixed cost is 720,000. Contribution per unit is 360. So 720,000, 3.6, 200,000 nets. Yes, okay. Then in value, well, just take 200,000 times the selling price of 12. That would be 2.4 million euro. €2.4 million, right? And number 4, margin of safety. MOS. Now, your margin of safety would be in units and in value. In units will be budgeted sales units minus break-even sales units. Okay, 540,000 minus 200,000, so that would be 340,000 units. And in value, we take 340,000 times selling price of €12. Okay, so 4.08. It's as simple as that. They didn't ask us to work out the margin of safety ratio, so there's no reason to calculate the ratio. Margin of safety is very, yeah. So question 2 and 3, not too difficult, I think. Yeah, fairly straightforward. Yeah. Okay. Now I'm going to look at break-even charts. Yeah. Now I'm not sure if break-even charts will be asked in the exam. I think if the exam is in an exam hall, wherever you are, if it's an exam hall, and if you have to, if you have to sit and do your exam pen and paper, then you might be asked to do this break-even chart. I use the word, again, emphasis on the word might be asked. I can't be certain, right? Yeah. But I think if it's an online exam, you would probably not be asked to do a break-even chart. Okay, yeah. So take a look at break-even chart. Yeah. A break-even point can be determined graphically. A break-even chart is prepared showing on the total axis the sales output in units, horizontal axis that way, and the vertical axis is revenue and posts. All right, following lines then drawn. Watch. I can do it here. Now, let's say I got a graph like that. I have a line like that. Watch, I'll label the lines, don't worry. Cost. total cost, right? Now, sales, fixed cost, straight line, not changing. This is, sorry, let's talk to the graph. Sales line starts the origin, zero sales volume, zero sales revenue. So sales line starts at the origin, zero. Can you follow? Right, yeah. Then, I don't want this, sorry. Fixed cost line runs above and parallel the horizontal axis, point on the vertical axis denoting the total fixed cost. So straight line, parallel to this is sales volume units. This is a value, so it will be like that in euro, currency of the examiner, all right? And then total cost, which starts at the point where fixed cost line meets the vertical axis, ends the point at which represents the horizontal axis, as versus the vertical axis, blah, blah, blah. Well, long explanation, but simple English, this one is total cost. It starts from the point where fixed cost starts. But of course, total cost is rising because the difference between total cost and fixed cost is variable cost. Okay. I mean, I'm sure you've done this before at an earlier level. All right. Yeah. Okay. Then the break-even point is the intersection of the sales and total cost line. Intersection of the sales and total cost line. So which means where sales and total cost intersect, let's say I use this line. That point there is break-even point in units. Now, if you read the graph, that way, you get break-even point in value. Can you follow? All right. I mean, if you look at the notes, I don't think the notes are very good because it's just talking. You know, I think if you're going to show a graph, you should have the graph drawn and in your notes so you get an idea of how it looks like. Graph is supposed to be a visual presentation. Am I right? Yeah, so talking in words about something that is visual, I don't think that's a very good way of doing it. So I hope by looking at this graph, you have an understanding of, well, you know, what the break-even point graph is. Yeah. Now, just remember one thing. Yeah. Until you reach your break-even point, all this is losses. All right. To explain my point, here cost exceeds revenue. So all this is loss. But if you go above, sales revenue exceed cost, this is profit. You understand? Give you an idea of what profit or loss is. Yep. Okay. So you got that? I'm certain you have done this graph before. Lower level studies, I would assume, right? And here we go. Yeah. It says the break-even point intersection sales line and total cost line. Number of units represented on the chart by the distance between the break-even point and expected sales units indicates a margin of safety. Yes. Now, cost volume profit analysis. What are the purposes? To provide information and management about cost behavior for routine planning and decision making. To determine what volume of sales is needed at any given budgeted sales price in order to break even, and to identify the risk in the budget by measuring the margin of safety. Higher the margin of safety, less the risk. But if you have a small margin of safety, then you have high risk. Yeah. Calculate the effects on profit of changes in variable costs, profit volume ratio, sales price, and volume. All right. Now look at example 7. Yeah, it says the budgeted annual output of factory is 120,000 units. Fixed overhead amounts to 40,000 euro. Variable cost per unit. Average sales price is $1. Construct a break-even chart showing the current break-even point and profit earned up to the present maximum capacity. Right now, we don't have graph paper, so what I'm going to do is I'm going to do a little bit of calculations first, just to show you the key points on the graph, right? So watch. Now, first of all, we have variable cost 50 cents, selling price is 1. So we have contribution per unit. 0.5. Then break-even point in units. Fixed cost is 40,000 over 0.5, so 80,000 units. Fixed cost is 40,000. All right, and your break-even point, and then you have your break-even point in sales revenue. €80,000, right? Okay, so I'm going to construct the graph. Okay. On this, okay, right. Draw all the line that is sales. Costs. Again, yeah. Sales, total costs, fixed costs, units, revenue. Right. Okay. Now, let's say this is thousands. Units also, let's say thousands. Yeah. So fixed cost will be 40,000. This point will be 40,000. All right. This point here must be break-even point 80,000. This is break-even point in euro. Over here, is the of 80,000. Yes. Okay. So this is 80,000 units also. All right. And this is break-even point in units. That's 0. Now, you expect to sell, oops, not this. You expect to sell how many units? 120,000 units. So, somewhere here is 120,000 units. This is budgeted sales. So 80 to 120 is your margin of safety. $40,000 units. You understand that? I mean, I don't have graph paper, but if you do a graph paper, you can graph it correctly. What I am doing is I am actually marking the key points using these workings here. Can you follow? Please check your calculations. I mean, later you can draw it on graph paper. If you have graph paper at home, just take out graph paper and give it a try. Yeah, not be too difficult. All right. Any questions, all of you?
Hello, mate.
All right. Okay. Now let's move along. Yeah. Please turn off your mic if you're not talking to me. Yeah. All right. Okay. Moving on. We are looking at this example 8. All right. It says a company manufactures 4,000 units of product, which is the variable cost of 15 euro per unit. Selling price 23, fixed cost 25,000. Target profit is 10,000. Construct a break-even chart showing the break-even point, margin of safety, and the profit. Okay, selling price 23, variable cost is 15. So example 8, we have contribution per unit 23 minus 15, 8. Break-even point units is fixed cost is 25,000. Over 8. So 25,000 divided by 8 is 3125 units. Break-even point revenue times 8. $25,000. Not 8, sorry. Selling price is 23. That is 71,875. Okay. Sales to achieve a target profit of is 10,000. So we take fixed cost 25,000 plus the target profit 10,000. Contribution per unit is 8. Well, this is interesting because you're only manufacturing 4,000 units of a product. All right. So if you want to get a profit of 10,000, you have to manufacture more than 4,000 units. All right. Yeah. Okay. So now we do the graph here. So we draw that. Fixed costs. Sales. Total costs, fixed costs. It's in euro. This is units. Now fixed cost was 25,000. 25,000. Break-even point revenue is 71,875. So not drawing to scale. So this is 71,875. I'm not drawing it to scale, obviously, as you can see. Not important. You can do it to scale if you have graph paper. Units 3125. Production is 4,000. This is break-even point in euro point in units. This difference is your margin of safety. 875 units. Check. Yeah. So again, that gives you an idea of what is your margin of safety. It's not too difficult, I think, this kind of questions. Yeah. Now, the next graph is interesting. Yeah. This is sorry. The next one is called the profit volume chart. Okay. Now, a profit volume graph, it's a type of break-even chart, but the way it's presented is slightly different, right? Yeah. Now, it says a profit volume graph is defined as a graph showing the effect on contribution and on overall profit of changes in sales volume or value. And profit volume graph identifies the profit or loss by indicating the amount of changes in volume or profit. Sales volume is plotted on the horizontal axis. Profit and losses are represented on the vertical axis. Vertical. All right, yeah. And sales volume, horizontal. Horizontal, vertical. Vertical is profit losses. Horizontal would be your volume, yeah. Look at example 9. Company manufactures 4,000 units of product, which is variable costs of 15 per unit, selling price 23, fixed costs are 25,000, target profit is 10,000. Construct a profit volume chart showing the break-even point, margin of safety, and the profit. Now, again, I don't have graph paper, so I'm going to do it here. Now, profit volume graph, the shape of a profit volume graph is a little bit different. It will be something like that. Okay. Now, this is in value. Now, above 0 is profit, but below 0 is loss. The graph will start, if you don't sell anything, this is sales units. If you don't sell anything, that means your loss will be equal to your fixed cost. Fixed cost, this example, is 25,000. All right, now this point here is a break-even point. So let's do some calculations. All right, now contribution per unit will be 23 minus 15, that will be 8. Fixed cost 25,000, break-even point units 25,000 over 8. 25,000 divided by 8 is 3125. So this point here is 3125. Now your break-even point, actually the figures here are the same as earlier, isn't it? Yeah, same thing. See, 15, target profit 10, it's all the same, yeah, right? Except the graph is presented differently, yeah. So anyway, 3125, target profit 10,000, you need to sell 4,375. So if this is 4,375, that figure here would be 10,000. Can you follow? So profit volume graph, this is a profit volume graph. Profit volume graph just presents information in a slightly different way. That's all. All right. Will this be tested in the exam? I don't know. I'm of the opinion that if your exam was in an exam hall, you might be asked to do a break-even graph, because it'll give you a graph paper and you can draw it on the graph. Yeah. But if your exam is computer-based, if it's an online exam, I'm not sure if this will be tested, because it'd be difficult for you to draw a graph on a computer. Actually, you can do it on Excel and convert it to graph, but can't see the examiner testing you that way. All right. Yeah. So let's see how it goes. Yeah. As of now, I mean, your exams, your finals only next year. April, is it? And April, March, and April, May, something like that. Yeah. So as far as your finals are concerned, I think that's something you worry about later, not now, right? Profit volume graph. Okay. Now, limitations of profit of CVP analysis, right? Yeah. Cost volume profit analysis is a useful analytical tool, but it isn't perfect. There's no such thing as a perfect analytical tool. Yeah. All types of analytical models are based on assumptions. You know what I mean? So if your analysis is only as accurate as the assumptions you make. Can you follow? Right? Yeah. So limitations of cost volume profit analysis. The limitation of this type of analysis lie in some of the underlying assumptions. It is assumed that number one, costs are either fixed or variable. True. Fixed and variable costs can be correctly separated over the whole range of output. That means all costs can be analyzed into variable and fixed costs. As I'm going to show you in an actual, there's a past year question that we're going to look at after this. Often in practice, identifying what is the cost into its subcomponents exactly is not so clear cut, right? Continue. Selling price is constant. There's only one product or constant sales mix. Production and sales are equal. What you produce, what you sell, there's no opening, closing stock. No change in anticipated regard to efficiency. Again, it's a major assumption, all right? And volume is the only factor affecting cost, and that all other factors remain constant. All right, these are all the key variables, key limitations, I would say, of the model. All right, yeah, next. Now we've finished with this lecture note. I want you to look at this question, yeah? This was a question, I think it was, according to the examiner, is June 15, yeah? June 15. It's an actual past year question, so let's take a look at this question now. All right, it says you have reviewed 5 months production and cost data in one of your, not in one of your plants, no, in one of your plants. Volume is given. You've got October, November, December, January to February. You have total cost given there, as you can see. Item produced in the company is sold for €500 per unit. Company uses an absorption costing system, and the composition of variable cost for each item is as follows: direct material 30, labor 55, variable 15%. Yeah. A lot of many sub points. So I think, I mean, assuming it's 25 marks, I think the mark breakdown will be like 2-3 marks, or maybe even 1 mark per question, right? For example, A, what is the total number of units produced over the 5 months, October to February? And what is the total cost of production of the 5 months, October to February inclusive? A and B is, I think, pretty straightforward questions. Before you read the rest, let's work out A and B. This is June 15. All right, we have month, October to February, October, November, December, January, and February. We have production units, and then we have, don't want that, we have total costs, euro. Yeah. Now your production is 459,945. 326,244 and 326 again. Okay, so you want total production part A, all right? So I will just add that up. 2,300 units. Total cost is 348,439,245. 439,245. Then this 317,070. 317,070. 299,035 and 319,020. Okay, and for doing that, you've done part A and B, but it seems kind of very simple, I think. Yeah, right. Not sure why he's asking you that. Over the 5 months, total cost of production over the 5 months, right? Now, based on production data for the 5 months, your workings in part A, yeah, and part B above, what is the average unit production cost to 2 decimal places? All right, so average unit production cost will be 1722370 divided by 2300 units. Right. Examiner wants the answer in 2 decimal place, 748.86. Shall we say?
Sir, sorry for interrupting. The total cost for November should be 439,235.
439,235. So that must be 2360. 60. Please check. Yeah, sometimes I do it very quickly. I make a mistake sometimes. 748.85. Yeah. Is the rest of it correct? Please check. 348, 439, 235, 317, 070, 299, 035, 319, 020. All right. Selling price is 500 though. Right. Okay. Look at part C. Yeah. This I'm finished. What is the total profit for the 5 months? Now we sold, cannot be a profit. It's a loss actually. Is my calculations correct? Let me check. Volume is 459,945, 326,244, and 326. All right. 341, 313. Yes, looks about correct. Yeah. Okay. So next, total profit or loss, sales revenue will be 2300 units multiplied by 500 per unit. Plus total costs. You end up with a loss here, yeah? 1,722,360. That minus E14 total Can you follow? It's not a profit, it's a loss, yeah? Next, D. D, using the high load technique, calculate the variable cost and the fixed cost of production, yeah? So we have high, low, we have units and total cost. Now, high is 945 and low is 244. All right, at 945, cost is 439,235. And at low is 299,035. So we have the change that is 945 minus 244. And that is 439,235 minus 299,035. All right, so we have, let me double check, yeah. Variable costs, fixed cost of production, yeah. Variable cost per unit, 140,200 divided by 701. 200. Now, to find the fixed cost, we take total cost minus variable cost. Okay. Now, you can do this analysis for any period because common sense will tell you that fixed cost must be constant. That is one of the assumptions we make. All right. One of the assumptions we make is that fixed cost has to be constant every month. Yeah. So let's say we take October. Say October. All right. So FC October total cost is 348,000. Now variable cost must be number of units in October was 459. multiplied by 200. Two, 5, 6, 200. Now, if you take a different month, your answer should be the same. I mean, if you take a calculator and check, let's say you take November. If you take 439,235 minus 945 times 200, okay. How am I getting different? Sorry. Let me double check that. We got variable cost as 200. Fixed cost, take January 299035 minus 244 times 200. I got 250. Right? Did I make a mistake here? How come the answers are changing? Shouldn't change. Should be fixed costs be constant in all range. Let's say I take November. All right. If I take November, 439,235. 439,235 minus 945 times 200. Actually, it should be same, but 235 minus 45 times 200. I don't know why it's different. It should be the same. Yeah. Fixed cost. All right. Next part E. We are doing cost per unit. Cost per unit. Now, to be consistent, I'm going to using November data. Okay. Now, total variable cost must be total cost minus fixed cost. Okay. Now, the total cost for November, 439,235. 439,235 minus fixed costs, which is 250,235. $189,000. So we have direct material, direct labor, and variable overhead. Material, direct labor, and variable overhead. Okay. Now, for direct material, it will be $189,000 multiplied by 30%. Right? So 30%. Direct labor is 189,000 times 55%. Variable overhead is check 15%. Okay, 30, 15, 45. Yep. Okay, so total that would be all right. Total that would be 189 times 30%. 189 times 55% times 15%. So you want to find the cost per unit. Now, for November, the number of units you make is 945. So that must be 56,700, 945. That must be 103, 950, 945, and 28350 divided by 945. $103. Sorry. Right, we can analyze the total as well. If you add this up, you must get 189,000 units, 945. Two ways again, you take 189,000 divided by 945, or you add up everything. You should come back to 200. That should be 200. The figure we calculated above that. Okay, follow? All right. Now, of course, an alternative way of doing it, you could have done it like this. You got the per unit, just take the per unit multiply. Or 200 times 30% and so on and so forth. You could have done that as well, right? So let's look at part F here. What does F ask us to do? Sorry, am I going too fast? Can you follow? Your answer? Is that right? All right, that's another way to do it, yeah. Okay, now if you go to F, if the direct labor cost represents 120 minutes of effort, what is the hourly labor rate? Well, it's very simple actually, yeah. 120 minutes equals to 2 hours. So direct labor is 110. So labor rate per hour will be 110 divided by 2 hours will be 55 per hour. Can you follow? F G. G, what should be what is the contribution, well, not what is the contribution per unit and profit and 500 units are produced. All right, now contribution per unit at 500 units must be constant at whatever number of units, yeah, but 500 units assume 500 units are made and sold. Selling price, variable costs. Selling price is 500, variable cost is 200. So contribution per unit. Per unit is 300. Sales. Units, 500. Total contribution, 300 times 500, 150,000. Less fixed costs. Now, fixed costs, we worked it out as here, 250,235. 250,235. And we actually have a loss of 100,235. So loss per unit. Question is tricky because the question said profit per unit, but at 500 units, you don't make a profit, yeah? So that would be 100 approximately, yeah? This is your answer. That's your answer. Right? Okay, now comes next, EFGH, break-even number of units. So break-even number of units, fixed costs divided by contribution per unit. Okay, so your fixed cost is 250,235. Contribution per unit is 300. 35 to 300. Say 834 units. Right. It's a rounded up answer, yeah. HI, right? Next, break-even number of units, margin of safety in November. Margin of safety, MOS, in November. Now, we know margin of safety is expected sales minus break-even sales. All right. So expected sales is 945 units in November. 945 units, but your break-even sales is 834. So that should be 111, correct? 945 minus 834 is sorry, 834. 111 units. And then, sorry, can you follow? Please check. Right. Then we have IG. Okay, what does J say? Let's see. Last part already. It says if after more thorough investigation, fixed cost fund be actually 220,000, what would the real break-even volume be? Fair enough. So assuming the fixed cost is actually 220,000. The break-even point should be 220,000 divided by contribution per unit was 300. Yes. You will get the funny number. Unit. Right. Not too bad. I think the question is not too bad. Yeah. With a little bit of practice, I think you'll get the hang of it. If you do get a CEP analysis question in the exam, I don't know if you will get. I'm saying if you do get, yeah, I can't see the future. If you do get it, your CEP question would be something like this. Yep. All right. Yeah. Subsections with changes. I mean, that's what CEP analysis is all about. It's about finding out how individual variables changing impacts on cost, impacts on volume, impacts on profit. Yep. Okay. So we're done with this question. And we're done with CEP analysis, right? Yeah. Okay. So we're going to look at the topic of decision making. All right. Yeah. Now, decision making essentially is the topic of choosing, making choices. All right. Yeah. The word decision making implies that you have to make a choice, a decision, right? Now, when you have to make a choice, it implies there must be many alternatives. So decision making is simply about making the right choice. Yeah, choosing between different alternatives to come to a solution. That's what decision making is all about, right? It's a question of choice. That's what it is. Yeah. So this topic of decision making, all right, we can have single period, multi-period, you know, things like that. Yeah. But as far as year 2 costing is concerned, you will not be asked multi-constraints, multi-product, multi-constraint, because that would require a linear programming solution. And linear programming is, of course, something that is examinable in year 3, not in year 2. All right, it's a future lesson, yeah? All right, okay. Before we start on this, let's just take a look at the type of decisions, right? Yeah. Decision making says these are decisions which seek to make the best use of existing facilities, and typically in the short run, short term, yeah? So we will apply marginal costing principles, okay? Decision making in the short term, will involve the application of marginal costing principles. So that means quite a lot of the assumptions that we made in cost, volume, profit analysis will still remain. Yeah, those assumptions will not change. They will remain there. All right. Yeah. Okay. So if we read that again, these are decisions which seek to make the best use of existing facilities. Typically in the short run, fixed costs will remain unchanged so that marginal cost, revenue, and contribution of each alternative is relevant. Yes. So as you can see, the application is marginal costing, not absorption costing. All right. And as far as short-term decision making is concerned, we are assuming the same CVP assumption, which is relevant range. Yeah, we are assuming that within that relevant range, yeah, don't forget the concept of relevant range, and within the relevant range, these are actually assumptions. The usual assumptions are fixed costs in total is constant. If we see a change in fixed costs, right? If we see a change in fixed costs, then it's no longer the relevant range. All right. Fixed cost in total is constant. Number two, variable cost per unit is constant. And number three, selling price per unit is constant. Unless the question creates a hypothetical scenario with instructions telling you certain things are changing. But by and large, listen, by and large, these are the usual relevant range assumptions. Now, these assumptions, we picked it up in the topic of, these assumptions in the topic of cost, volume, profit analysis. But it will also be applied in the context of decision making. So even in decision making, we assume that these assumptions are constant, short term, yeah. And because the decision making is short term, another key point, as the decision making is short term, this implies that a time period of less than 1 year, time period of less than 1 year applies. All right, implies the time period of less than 1 year applies. Yeah, so the decision, the outcome, everything is within 1 year. All right, yeah. Okay, now because it is within 1 year, therefore, the time value of money is ignored. Right, time value of money, the NPV concept, time value of money is ignored as all cash flows and outcomes occur within a 1 year period. In less than 1 year, everything is done and finished. Yeah, all the cash flows, all the outcomes, etc. It's all within 1 year, and that is why we apply this principle. All right, yeah, short-term decision-making principles. Can you follow? Right? Okay. Now, if decision-making is long-term, let's say the impact of a decision goes beyond 1 year, goes to 1, 2 years, 5 years, whatever. Yeah, then the method of making a decision becomes NPV analysis. That's different. Yeah, different from what we're doing right now. And most probably NPV analysis is something you learn in financial management, right? You learn in financial management, not in costing or performance management. Yeah. So over here, not this here. All right. Yeah. So these are decisions which seek to make the best use of existing facilities, typically in the short run. Fixed costs will remain unchanged. Yes, we assume fixed costs will be constant. All right, so that marginal cost, revenue, and contribution of each alternative is relevant. Yeah. In these circumstances, the selection of alternatives which maximizes contribution is the correct decision rule. Yeah. Focus is on maximizing contribution. Why? Because in that short period of time, all your fixed costs will be constant. Correct? So because fixed cost is constant and unchanging, remember relevant range, the decision will be based on which option maximizes contribution. Can you follow? Right? Yeah. Now, special decisions include the following. Now, these are the most common type of questions one can expect in the exam. Number one, product mix decisions with capacity constraints. That will be like limiting factors. I will elaborate on limiting factors in more detail afterwards, shortly. Yeah. We'll take a break shortly. Yeah. And we'll also have to make or buy decisions. Yeah, we will come to that point also shortly. All right, we'll take a break. Listen, we'll take a break, and then when you come back, we're going to start going into types of decisions. I will expand and give examples. Right? Yeah, we'll take a break. All right, let's get back to our notes. Okay, now to admit everyone. Yep. Okay. Right now, as I was saying, yeah. Before we took our break, I pointed out the logic of this topic of decision making. Why we have this topic, right? Yeah. And decision making is needed. It's a methodology, right? The methodology is needed because we have alternatives, correct? Alternatives, and we have to choose between alternatives. All right. It's the classic economics problem. It really is an economics problem. Yeah. We have many wants, many things we want, but we have a limit of resources. All right. We don't have unlimited resources. We have many wants, but insufficient resources. Then that's the key issue to think about here. All right. Yeah. So if you talk about these types of decision now, essentially there's so many kinds of decisions. Yeah. So what we're looking at here is examples of the kind of decisions that can be tested. In real life, it's not restricted or limited to what you have in your notes. Everything in life is a decision. Yeah, you get up in the morning, what you're going to have for breakfast, that's a decision. It's a decision that is based on what you feel like eating and how much money do you have. Do you know what I mean, right? Yeah. And of course, there are non-financial variables. What do you enjoy, correct? How healthy is your breakfast, so on and so forth. The list goes on. You know what I mean, right? How do you plan to come to college? Are you going to drive? That depends on whether you have a car. Should I buy a car? That's another decision. Should I take a bus? Should I walk? Should I take a Grab ride? Should I take the train? There's so many decisions. So as I keep pointing out to my students, every aspect of life is about making choices, okay? And if you have no choice, then there is no decision to be made. I hope you follow what I'm saying, correct? But given that everything has choice attached to it, a decision will have to be made, yeah? Now, the word limiting factor, yeah? The term limiting factor has many different meanings to it, all right? So, some textbooks call it limiting factor, some even call it principal budget factor, all right? Principal budget factor, and it is a constraint that prevents an organization from becoming more profitable, right? It's any constraint that stops you from being more profitable. Now, many kinds of constraints. It could be machines, right? You have a shortage of machinery in your factory to manufacture your product. What do you do? How do you solve this problem? All right. You see, a lot of decision making is identifying what's stopping you from becoming more profitable and how to overcome that limitation. You know what I mean? Yeah. What's stopping you and how to overcome the limitation. So let's say I don't have enough machines. What can I do? Solution is not go and buy a machine. Buying a machine is expensive, not cheap, correct? So normally what we try to do is we try to solve the problem in other ways. For example, can we work overtime? Yeah, our normal factory works, let's say 9 to 5. But in order to fulfill demand, maybe we can work overtime. We can work until 7 o'clock, 8 o'clock in the evening or something like that. Yeah. Alternatively, we could introduce shift work. All right. I know in many companies, manufacturing often has shifts. All right. Why? Because demand is very good. Yeah. So you work, say, one shift 9 to 5, another shift starts in the evening and finishes late at night. Yeah. So, you can have shift work. Let's say the constraint is short term. So maybe to overcome the problem of a lack of machines, maybe you can outsource manufacturing, find somebody to do contract manufacturing. So you get someone else to make the product, you bring it into your factory, and then you just put your label on it. You get what I mean? That's been done. Quite a lot of companies do that. Now, of course, if there is absolutely no way to overcome the machine shortage constraint, then you would think about buying a machine, correct? But buying a machine is usually often the last resort, because remember, you don't want to have the opposite problem. See, at the moment, we don't have sufficient machine capacity, assuming that's your constraint, yeah? Right? But in the future, if you were to buy a machine, then you could have the problem of overcapacity. All right, from under capacity, you end up with overcapacity. So something to worry about. Yeah. Please understand that these constraints, it can be machine, it can be labor availability, it can be space availability, it can be finance, so on and so forth. Understand that in the context of decision making, these are short-term constraints. All right. The argument being, in the long term, you should be able to overcome these constraints, and these constraints won't be in existence anymore. All right. Yeah. That's the essential assumption. Sorry, I don't want this. I am here. All right. Okay. So it says limiting factor. What is the limiting factor? Binding constraint. Yeah. But the many constraint. Binding is a constraint that really stops you from becoming more profitable. All right. Binding constraint upon the organization, i.e., the factor which prevents indefinite expansion or unlimited profit. So the word constraint stops, it blocks, prevents you from becoming more profitable, prevents you from generating higher profits. That's what a constraint keeps you in, yeah, instead of being able to move out, yeah. And it says it may be sales, availability of finance, it can be skilled labor, it can be supplies of material, or it can even be lack of space. All right, so all these are examples of possible constraints. Can you follow? It says where a single binding constraint can be identified, then the general objective of maximizing contribution can be achieved by selecting the alternative which maximizes the contribution per unit limiting factor. All right, so simple example, yeah, simple example. Let's say you are in a particular month, let's say the month of January 2022. Now you have forecast machine hours available of, let's say, 20,000 hours. This is assuming your machines operate at maximum capacity. But let's say machine hours required to meet demand is 25,000 hours. So what we have here is what we call a binding constraint. I need 25,000 hours, but I only have 20,000 hours. So let's assume you have 3 products you can make. 3 products, you have product A, B, C. Now, you need 25,000 hours to meet demand, correct? But as it stands, you only have 20,000, which means there's 1, maybe 2 products that you might have to reduce the number of units you're going to make. All right. So I'll put this in red. Machine hours will be allocated to those products that maximizes, right? Machine hours will be allocated to those products that maximizes contribution per machine hour. It makes sense in, again, applying the relevant range assumption. All right. Within that relevant range, remember, fixed cost is constant. So our decision must be based on marginal costing. Marginal costing, selling price constant, variable cost constant, contribution is also constant. So we will choose the product that maximizes the contribution for every machine hour. Machine hour being the constraint, the binding constraint. This comparison, you compare with this, implies that machine hours is a binding constraint. When we say binding constraint, it is preventing the company from becoming more profitable. Can you follow? It's preventing, it's stopping you from increasing your profits. All right. And because it is stopping you from increasing your profits, well, it's a constraint. Yeah. How we do it, the calculation is actually not complicated. I think, and I've seen this before, I think the way the examiner can make your life difficult is if he doesn't tell you that something is a constraint. All right. That means he'll just basically give you a table, put the product demand in, all right, and then expect you to figure out that there is a constraint. Yeah. See, to give you an example, let's say you've got 3 products. Okay, watch example again. You've got A, B, C, expected sales demand 10, 20, and 30,000. And then you have, let's say, machine hours required per unit. Let's say 1 hour, 1.5 hour, and let's say 2 hours. Okay. Now, let's say machine hours available is 75,000 hours. Now, one of the questions that might come out of the exam, I use the word might, yeah, because I'm not the examiner. I don't set your paper, correct? So I cannot tell you what will or won't come out. I can only teach you to the syllabus. Get it? Yeah, your syllabus says these things are examinable, these things you are required knowledge. I can teach you to that, yeah. But if you ask me, will this topic be coming out for the exam? I don't know. All right, yeah. As I said, I don't set the paper. Okay, so simple question. Can we meet sales demand? All right, so we have product A, B, C, sales demand we have machine hours per unit, total 1, 1.5, and 2. 10,000, 30,000, 60,000. All right. So in total, we need machine hours required, 100,000 hours, but machine hours available is only 75,000. So which implies we don't have sufficient machine hours to meet our demand, correct? Not enough. So therefore, this means that machine hours is a binding constraint. Can you follow that? All right. And then, of course, the next working will be contribution and work out how much is the ranking and things like that. Yeah. So watch. Let's extend the example. Additional information. Yeah. Now let's say you've got product A, B, and C. Contribution per unit. Right. So let's say this is 10. Let's say this is 30. And let's say this is 15. Now, our constraint is machine hours. So we have to do another working, all right? Contribution per machine hour, euro 10 divided by 1, 10, euro 30 divided by 1.5 hours, so that's 20. 15 divided by 2, 7.5. So when we allocate the hours to the product, we follow this ranking contribution. Now, the mistake people make is they rank based on the contribution per unit. No. If your constraint is machine hours, you have to rank based on contribution per machine hour. Remember what I said? When you have a binding constraint, the idea here is you want to allocate the machine hours to where it can generate the highest contribution per hour. B will be ranked 1, A is 2, C is 3. So optimal production and sales plan. We do a simple table. Product. Now, units multiplied by machine hours per unit, total machine hours, right? Now, following the ranking, I'll start with B, okay? Now, B, demand is 20,000 units. So, if I take 20,000 times 1.5, I need 30,000. All right. I brought in the additional information over here, 1.5, yeah? Now, following the ranking, number 2 will be A. That's 10,000 units demand. Expected sales demand is 10,000. And so, times 1, 10,000. Lastly is C. Now C, our maximum demand is 30,000. But I cannot make 30,000. All right, I cannot make 30,000 simply because we already established that we are short of 25,000 hours. All right, so watch. Draw a line. Total machine hours available, 75,000. Correct? Yeah. So 30, 10, 75, that gives me 35,000. Balancing figure. All right. Now I need 2 hours per unit. So I work backwards. All right. This being the figure that I don't know. So 35,000 divided by 2, I can only produce 17,500 units. Now total, I need how much? Total, I need 60,000 hours if I want to make C, correct? But we only have 35,000. We're short of 25,000 hours. I mean, you can check with the calculator. If you take 60,000 minus 35,000, you will get 25,000. All right. And over here, 100,000, 75,000, the difference is short of 25,000 hours. Do you follow? Right. Yeah. Okay. Now that's a simple example, right? Yeah. And if we had more machine hours, we could have produced more. This example, this is what I mean. I've done it on board. I just simply threw in random numbers just to get you thinking. You will look at actual questions in your notes, yeah. But essentially, the whole idea of this example is to get you thinking. So get you thinking about what is limiting factors. How do these constraints work? Or how does it impact on your ability to produce and sell? Can you follow what I'm saying, all of you, right? Yeah, okay. So we are looking at this, all right, limiting factors. And here we go. Right, let's read that again. It says, it may be sales, availability of finance, skill, labor, supplies of material, lack of space. Listen, there are so many constraints a company can have. A company can have a shortage of labor, in which case you can train workers or you can use automation. You may have shortage of finance, but of course, if you're short of money, you may still be able to raise capital depending on your credit rating, size of company, ability to borrow and such, yeah. You may have shortage of material. You could look for alternative material, or you might think about importing material from another country. It might be a lack of space. So you can think about, how can I increase space availability? Do you follow, right? So there are so many ways of overcoming limitations. But I always believe, and I've always tell my students this, your ultimate limitation, your ultimate constraint is your ability to sell. Yeah, market demand is your ultimate constraint. There is usually, in almost all markets, an upper limit of the maximum demand for that product. Now, when I say maximum demand for a product, please take into consideration the fact that there are always competitors around you. Correct? So it's not just you selling that product, there are other people selling the same product. You know what I mean, right? So you have to take that into consideration as well. All right, yeah. So you read that, it says, where a single binding constraint can be identified, then the general objective of maximizing contribution can be achieved by selecting an alternative which maximizes contribution per unit limiting factor. And that's what I did in my example over here. All right, contribution per machine hour, this calculation over here is contribution per limiting factor, which is in our example is machine hours. All right, contribution per limiting factor. And next, it says where a single binding constraint can be identified, general objective maximize contribution limiting factor, right? Okay, now look at the method. Calculate the contribution per unit for each product. In my example, I gave you the contribution per unit. Of course, the actual exam that may not be given, you probably have to calculate and figure that one out. It's a possibility there. That's what will happen in the actual exam. And then calculate the contribution per unit of limiting factor for each product. So in this example, we determined that machine hours was a constraint. So our next working was to calculate what is the contribution per machine hour, all right? And then allocate scarce resource product to produce those products with the highest contribution per limiting factor. Hence, we have our ranking. The highest contribution per limiting factor in my simple example is product B. It generates the highest contribution for every machine hour that we utilize, all right? Rank second is A, and then C, yeah? So we allocate accordingly, and that will maximize our contribution, right? Okay, take a look at this example, all right? It says Autos are a major European producer of automobiles. Department within one of its divisions supplies component parts to firms operating in the automobile industry. So simple English, they make components. That's what it is, yeah? All right. The following information is provided relating to the anticipated demand and the productive capacity for the next quarter in respect of three components that are manufactured within the department. So you have component X, Y, and Z. So you have contribution per unit. Now, again, this example, contribution per unit is already given. Machine hours required per unit of output. So each unit of X requires 6 machine hours. Y requires 2, Z requires 1. Estimated sales demand is given here, as you can see. Required machine hours for the quarter is 12, 4, and 2,000. Listen, how do you get 12,000? Simple. We take 2,000 hours times 6, 12,000 hours. For component Y, I need 2,000 units times 2, I need 4,000 hours. And for component Z, I need 2,000 units times 1 hour, I need 2,000 hours. So in total, I need 12 plus 4 plus 2. So that's 18,000 hours that I need. 12 plus 4, 16 plus 2 is 18,000. But read the next sentence. Because of the breakdown of one of its special purpose machine, capacity is limited to 12,000 machine hours per period. And this is insufficient to meet sales demand. You've been asked to advise on the mix of products that should be produced during the period. All right. Now, the products that you're making, all right, let me do it in Excel. So it's easier for you to read. Right. So we have products, which is actually components, NENTS, components. All right, now we have contribution per unit in euro. Machine hours per unit, and then we have contribution per machine hour. Then we have ranking. Okay. Now, the three products that we're going to make are X, Y, and Z. X, Y, and Z. right? Create a neat table. I mean, again, I don't think you'll be doing Excel, but you know, even if you're doing it on pen and paper, you got to make your answer look neat. Yeah. So contribution per unit. Oh, I don't want this. Sorry. Contribution per unit is 12, 10, and 6. 10 and 6. Okay. Machine hours per unit is 6, 2, and 1. 1. So contribution per machine hour will be 12 over 6, 10 over 2, and well, 6. Yeah, 6 over 1, right? So ranking, you'll choose the one with the highest contribution per unit ranking. That's first. That's second. And third. That has the lowest contribution. So can you follow that? Check my numbers are correct. Yeah, 12 over 6, 2, 10 over 2, 5, 6 over 1. Yeah. 12 over 6 is 2, 5, 6 over 1. Right. Okay. So now, optimal production sales plan. All right. We have product, units. The constraint is machine hours, I think. Let me double check. Yeah, machine hours. Per unit. Total machine all right, now all these are headings, so I'll make it bold. Now we have to follow the ranking. Yeah, ranking, the highest rank is Z. So I will start with Z. Okay. Now, what is the demand for Z? Z demand is 2,000 units. So why am I clicking this? Sorry, 2,000 units. And machine hours required is 1. So total is 2,000 hours. Z, then rank number 2 is Y. Now, Y, I need $2,000, everything is 2,000 units. So 2,000 units. Machine hours required is 2, 4,000. Last is X. Now, total machine hours available. Total machine hours available is 12,000. I mean, I need, according to the question, I need 16,000, correct? 18,000, sorry. Required machine hours, 12 plus 4, 16 plus 2 is 18,000, but I only have 12,000. So there is a limiting factor there. All right, yeah. So this one, balancing figure. So balancing figure 12 plus 2 plus 4, 6,000. Right, machine hours required per unit is 6, correct? And so working backwards, I can only produce 1,000 units. So I'll put a note there. The above is the optimal production and sales plan. Only 1,000 units of product X can be made due to a shortage of available machine capacity. All right. Demand is 2,000, but we can only produce 1,000. We are short. We don't have enough. We don't have sufficient capacity as such. Right. That is not an overly complicated question, is it? Right? Yeah. Now, this was example 1 here. Right, next. Moving on, yeah. Now, example 1, requirement. Next is example 2. All right. They have 2 different limitations here, yeah. Labor hours and material, right? Let's read the question. Example 2, it says, product WXYZ, you have selling price per unit given, labor is at €5 per hour, material is €1 per kg, and contribution is given as well. And interestingly, they've worked out the contribution per unit, correct? Yeah. And maximum demand is the same for each product, which is 5,000 units. All right. Based on above data, which is the most appropriate mix under the 2 following assumptions? Requirement number 1, labor hours are limited to 50,000 hours in a period. Material is limited to 110,000 kgs in a period. Okay. Now, we take the first one, but I'm going to do some preliminary workings. A fresh sheet. All right, the first one, labor hours are limited to only 50,000, was it? Yes. The period. Now, the first working, we need to work out. We have the product. Yeah, we need to work out the labor hours per unit. Now, labor is paid at €5 per hour, and we have €15. Yeah. So we have product, and we have 4 W, X, Y, and Z. Okay. All right. So we have 4 products. Okay, now the first one, I'm just going to show you the working is Euro 15 divided by euro 5. That must be 3 hours. Over here, 10:35:25. So 10 divided by is 2 hours. $35, yes. Sorry, space 35 to 5 should be 7 hours. To 5 to 5. And that is 5. Okay. Labor hours per unit. Next, we need to work out the contribution per labor hour. So we have contribution per unit. 8, 8, 16, and 14. 8, 8, 16, and 14. We calculate contribution per labor hour. So here we take 8/3. We take 8/2. We take 16/7. 16/7. The hell is giving me a bloody date? I don't want a bloody date. Yeah, sorry. 16 divided by 7 is 2.286. 286, and that bloody hell. And that will be 14/5, which is 2.8. So ranking. First, that 2.8 is second. This is third. And fourth. You follow? Again, I don't think it's overly complicated. It's just a matter of putting things in the right place. All right, yeah. Right, now over here, optimal production and sales plan. So we have product, units. Now, constraint here is labor hours per unit, total labor hours. Now, according to our ranking, the first is product X, and the demand for each product, if I recall, was 5,000. Yes, so 5,000 units. Now, number of labor hours per unit is 2. So 5,000 times 2 is 10,000. Rank number 2 is Z, 5,000 units. And ours is 5 times 5, 25,000. Except third is W, 5,000 units too. And number of hours is 3. 15 plus, no, I can't make 3, 35,000. Double check. How many hours do we have total? 50,000. 15,000. Yes, I can make. Yeah. 15,000. Because if you check 50,000 hours exactly, correct? So total labor hours available, but it also tells me that I cannot make this also tells me that I cannot make the last product Y. All right, I can't make Y. I don't have enough time. Yeah, so I'll put a note to that effect. As the above is the optimal production and sales plan, comma, assuming that labor hours are limited to 50,000 hours. Assuming that labor hours are limited to 50,000 hours. Okay. In this case, there is only sufficient labor hours available to make products X, Y, and Z up to their maximum demand. There is insufficient labor hours available to make product Y. Yeah, do you really have to explain that? Yeah, I think depends on exam questions, but as a rule, I know you cannot just do calculations and go away. You really have to give some short explanation of what you're doing, right? Yeah. Now, the second one, if you go back to your question, it says number 2, material is limited to 110,000 kgs in the period. All right. So,
Sir, the explanation
sorry.
available to make product X, W, and Z, not X, Y, Z.
X, sorry. WZ. Sorry, X, W, and Z. Sorry, you're right. W, not Y. Yeah. Available. Sorry. Yeah. X, W, and Z. Now, next, material is limited to 110,000 kilograms in the period. Right. So now we have to work out. We have product. Next one is workings. Material required per unit in kilograms. So we have W, X, Y, and Z. Product. Right, now we do the workings. Now the cost of material is 1 per kg. So actually we don't need to do the working, but I'll just do 1. 21 divided by 1. So I need 21 kg. Over here, okay, not 21, it's 6. So I need 6. This will be 18 over 1, 18, 10, and 12. 18, 10, and 12. It is given in value, but the cost is 1 per kg. So just divide by 1, you come back to the original value, right? Now, next we have contribution per unit. Which was 8, 8, 16, 14. 8, 8, 16, and 14. Contribution per kg of material. So that will be 8 over 6. That will be contribution 8 over 18. That will be 16 over 10 and 14 over 12. So we have ranking. Can you follow that? All right. Yeah, we take the first, we take contribution per unit divided by the material required in kg, we get that value, yeah? Now, highest rank is that, isn't it? First, that's the highest. Second, no, sorry.
Is it Y?
Y, you're right. First is Y. That is second. That is third.
That is
X is last. Fourth. Okay. 1.6, yes, Y, W, Z, and then X. Okay, so then we do this optimal production and sales plan. Optimal production sales plan. We have product, units, material required per unit, total material required, kg. All right, now following the ranking, we start with Y. Number of units is 5,000. Material required per unit is 10. 5,000 times 10 is 55,000 kg. Y, then W, 5,000 units, and 6, 5, 6, 6, yeah, 6, so 30,000. So Y, W, third is Z. That's 85,000. Z is 12. No, cannot make 5,000. Put that 12. Total is 110,000.
the total
Sorry?
material required for Y is 50,000, right? 50, not 55.
50, yeah, sorry. Yeah. 50,000, 30,000, 80,000. So here we can only allocate 30,000. I cannot make 5,000 units. So I'll put there balancing figure. All right. Put a line there. That total material available kg. So this one would be 30,000 divided by 12. I can only make 2,500 units of Z. Now it is X is the one we can't make. All right. So continue. The above is the optimal production and sales plan, assuming that the availability of materials is limited to 110,000 kg. Product Y and W can be produced to maximum demand, but only 2,500 units of product Z can be made. The finance product Z can be made. Product X cannot be manufactured. Right. A simple commentary, yeah, not something long and fancy, just a simple explanation of what's going on should be sufficient to get your marks. Okay, right now, keep clicking this, sorry. Now that's limiting factor decision, but the other one is make or buy decision. Yeah, listen, in a make or buy decision, what you're looking at is exactly what you're seeing. Do you make or do you buy? Correct? Yeah, when you have a particular product or a component that you want to make. Yeah, if you read that, frequently management are faced with the decision whether to make a particular product component or whether to buy it. Do you want to make it or do you want to buy it? Yeah. And it says apart from overriding technical reasons, the decision is usually based on an analysis of cost implications. Yes. Right. We have a choice. We have a component. We can buy the component from a supplier or we can make it in-house. All right. Yeah. So now we have to do a comparison and make a decision. Should I make it or should I buy it? Yeah. And again, the crucial point is to know which cost information to consider. It says in general, the relevant cost comparison is between the marginal cost of manufacture and the buying in price. Yes, marginal cost. The assumption here is that even if I decide to buy the component externally, I will still incur the fixed cost because it is a fixed cost. So the decision is essentially a comparison of the buying in price with the marginal cost of making. It says, however, when manufacturing the component displaces existing production, loss contribution must be added to the marginal cost of production of the component before comparison with the buying in price. Yes, sometimes there could be an opportunity cost. If I make this product, this component, the production capacity, you need to pull it away from another product that earns a contribution. So that's an opportunity cost. All right, yeah. Don't forget, in decision making, this term opportunity cost is an important term. The cost of the next best alternative foregone. All right, cost of the next best alternative foregone. Yeah, that's, well, opportunity cost. Okay, now back to this example 3. It says a firm is considering whether to manufacture or purchase a particular component. The name of the component is 2543. It's a code, I guess. Yeah, it's been batches of 10,000. Buying in price will be 650. The marginal cost of manufacturing component 2543 is 475 per unit. Component had to be made on a machine which was currently working at full capacity. That's interesting. If you're going to make the component, you're going to make it at full in a factory, in a machine that's already working at full capacity. Yeah? If the component was manufactured, it is estimated the sales of finished product FP97 will be reduced by 1,000 units. Interesting. FP97 has a marginal cost of 60 per unit and sells for 80 per unit. Advise the firm whether it should manufacture or purchase component 2543. Now, this is example 3. Yeah. Example 3. Cost of buying component 2543. That's a code. Now you need, how many components do you need? 10,000. Buying in price will be 650. So $650 per unit. So that will be 65,000 euro. Cost of making component 2543. Okay, now first we have marginal cost of manufacturing. Spelling error. Okay, marginal cost of manufacturing. And then we will have opportunity costs, contribution foregone on FP97. If you look at FP97, yeah, all right. Now, marginal cost of manufacturing would be 10,000 times 4. Let me check. 4.75. Sorry, 4.75 per unit. $47,500. Now, the opportunity cost, which is the contribution foregone on 2543, will be marginal cost of 80, 60, 80. So it will be 1,000 units multiplied by contribution per unit. Now, the contribution per unit is selling price of 80 minus the marginal cost of 60. Okay, so that would be 20,000. And total cost of making component 2543. That in bold, I will underline that, keep bold and highlight it. Listen, if I make, it's gonna cost me 6,500. If I buy, it's gonna cost me 65,000. So advice, yeah, based on the above calculations, the cost of buying the 10,000 units of component 2543 is cheaper, than making it. Now, if you observe carefully, the whole problem is the 20,000 here, isn't it? Correct? If there is sufficient spare capacity to make the 10,000 units, comma, then there won't be lost contribution on product FP97. Then making will be a cheaper option. However, as if you read the question again, all right, the machine is working at full capacity and 1,000 units will have to be reduced. However, as the machine is working at full capacity and 1,000 units of FP97 cannot be made. 1,000 units of FP97 cannot be made. This contribution foregone. Foregone means you give up. Is a relevant cost and it must be included in the decision making process. We cannot ignore it. We have to take that into consideration. All right, must be included in the decision making process. This is why the lowest cost option should be to buy the components. That's the lowest cost option. Can you follow? A short explanation again. Do you have enough time to give that explanation in the actual exam? If you don't have enough time, you just make the decision. You just say buying is cheaper. So, and just continue like that. Can you follow? All right. It all depends on how much time you have in the exam and how much marks are being allocated. That's going to influence your time allocation to answering the question. Okay. Now listen, there is one more question, one more example, example 4, but I will do this example with you tomorrow. You can try it at home. You can try it at home. I don't actually think this is a difficult question, yeah, but we'll do it tomorrow. And tomorrow I'm also going to look at all the decision-making questions, yeah. Question, relevant cost, decision-making, etc. Yeah, there's some questions on relevant cost as well, which are a little bit tricky, not easy. All right, yeah. So I will explain the relevant cost principles and then we can do the questions tomorrow. All right, yeah. Okay, so I'll stop here for today. You can try example 4. I don't particularly think this is difficult. All right, yeah, but give it a try at home and we will continue with example 4 tomorrow. All right, yeah. Thanks for joining me. I'll see you all tomorrow morning, usual time, 10 o'clock, 10 a.m. Right, bye for now, yeah. Bye.
All right. Thank you, sir.
Yes, sir.
You're welcome.
Thank you, sir.
Recording stopped.
Thank you, sir.